Well, maybe we'll get started. And as mentioned a few minutes ago, Mike is maybe starting parental leave, so I guess he's not going to make it today. He asked me to stand in. So it's great to be able to introduce today's presenter, Jeroen Ooms, who's done an amazing amount of work for R over the years. And today he's going to talk about the R Universe project, which I stumbled across and was totally impressed by. So really looking forward to the presentation and discussion that can come from that.
All right, thanks. Let me try to share my screen. I'll get my slides first. One second. There we go.
Yep, looks great.
All right. So thank you for the invitation. I haven't talked to this group before, so I wasn't quite sure what you would find interesting. So maybe you've heard about this project before or not, but I thought maybe it would be interesting to talk a little bit about the infrastructure side of this project. And then maybe we can discuss a bit how the infrastructure compares to that of Bioconductor. And there's probably some other things we can discuss. I don't use Bioconductor myself, but I'm aware that one of its unique features is that there's this centralized release cycle, which is different from CRAN. So maybe we can talk a little bit about if there is something that would work for our universe repositories and sort of concerns and so on. What is our universe? I'll give a brief introduction for people that haven't seen the talks yet. So it's our universe is a new ambitious platform by R OpenSci for publishing research and research software written in R. And the platform is completely free. Anyone can sign up, like novice R users, students, researchers, professional package developers. There's currently about 350 registered individuals and organizations together maintaining several thousands of R packages and articles. The major difference with something like CRAN or Bioconductor is that everyone manages their personal repository. So therefore, there is no gatekeeping and there's no centralized quality control. So thereby we try to hope to make this more accessible. So if you have something that you think is interesting to publish, some R code or an article or something you think is worth sharing, regardless of what it is, you can just put it in your universe. So this talk will mostly be about infrastructure, but I'll give a few other resources if you're after this talk completely confused what is this about. So if you want to learn more about the R Universe project, a good starting point is the R OpenSci homepage, where we link to a lot of other resources about how it works and what you can do. The recording from the Use R 2021 keynote is sort of a good general introduction about the project, sort of gives an overview of what we currently have and where we want to go, and like some examples of what you can do. There's also a talk from our StudioConf from January this year that focuses more on the scientific metric part of the project. So part of our project, we want to do something with metrics and with quality monitoring. So in that talk, I try to explain why we sort of believe it is important that organizations and potential users of software, they can get a sense of the health and the quality of the open source software that they want to build on. And then on our website, we have several tech notes on the blog site that go into various more technical aspects of the project, like, you know, how to get started if you want to set up your own universe, sort of what the build infrastructure looks like. Some of that I will also talk about in this presentation, and then some other things like about publishing reproducible articles, and so on. So briefly, what is our universe? So it's sort of an umbrella project under which we are experimenting with several ideas that we've developed over the past years in R OpenSci to try to take open science with R to the next level. In essence, our universe is an open platform for publishing and discovering research and research software written in R. The platform has many features and components, but the core is that in the system, everybody has a personal CRAN-like package repository based on Git, which is backed by a modern automated build system and allows you to publish packages with software, but also packages containing other research materials, such as automatically rendered R Markdown articles, or, you know, other research artifacts. And then on top of that, our platform provides like extensive dashboards and feeds and APIs and metrics and so on to try to make all of the content accessible and discoverable, both for humans, but also programmatically. Yeah, so how does it work? Every user of organization gets a unique subdomain under the runiverse.dev domain for publishing their content. And the subdomain is mapped to your GitHub account name. So it can either be an individual account or a GitHub team account. So for example, my personal account, jeroen.runiverse.dev, is where I publish personal packages. And then on the rOpenSci.runiverse.dev, we publish rOpenSci maintained packages.
Hey, there's a question in the chat. I don't know whether you wanted to deal with it now, or we can accumulate whichever you're most comfortable with.
Sure. What is the question?
Vince asks about what live reproducible means for articles.
So it means that the article is automatically rendered on the server, and so the user only provides the R Markdown file, which is, you know, it's a vignette in an R package. And the system automatically renders that and publishes the content. So there's no, the user doesn't, there's no R code being executed on the user machine. It all happens automatically. And also the system automatically re-renders that article on a regular basis. So if it contains like a, you know, like pulls data from a source that changes, or some of the dependencies changes, like automatically you will start seeing the output changing. But I will show that in a bit.
That's good.
All right. So under the main, you can find a CRAN-like repository for that user with the R packages owned by that user or organization. And these include binaries for Windows and Mac in the same structure as CRAN or Bioconductor itself. So R can easily install packages from there. And on that same domain, you can find the articles published by that user and a lot of other metadata. And if you open the domain in a browser, you can browse the content visually using a dashboard. But all of the data that we have and that we provide is exposed programmatically through HTTP APIs. So a brief example, this universe ggsec.runiverse.dev is the suite of R packages that's developed at the University of Oslo at the Department for Brain and Cognition Research. So the owner of that universe is the GGSec GitHub account, and therefore the universe is published under ggsec.runiverse.dev. So if you open it in a browser, then you see this. So there's a few, if you open it in the browser, you see a few tabs in the dashboard, and the first tab shows the builds tab, so you can see by date when the package was last updated, and then you can see some other data, like you see a green badge that shows that the package is available from CRAN, and then there's this column where you see that the binary packages are available for Windows and Mac OS. And if these icons are green, it means that the package has also passed all of its checks. And as I explained earlier, because all of this uses the standard CRAN-like structure, users can directly install packages using simply install.packages. And they can install packages just like when they would install from CRAN using the standard command. I realize now that Bioconductor uses another system to install packages, so maybe this is not a strong case. But for regular R users, this is like much easier than trying to compile R packages from Git or some other source. And so because the system automatically provides binaries for Windows and Mac, you don't need dev tools, or you don't need to set up compilers on Windows or remotes. Everything is taken care of at the server side. So from the user point of view, installing a package from a universe is just as easy as it would install from CRAN. And then the dashboard shows some other information about this universe. There's a tab with information about packages. So it sort of shows some information that mostly from the description files about which packages are in the universe and their logo, if they have one, and like the authorship and when they were last updated. And here, the articles tab shows the list of automatically rendered articles. So these are Markdown articles that are included as vignettes with the R packages, and that were automatically rendered as part of building the R package. So what the system does is that for all of the R packages, it automatically renders the vignettes, but then it overrides the theme so that all of the vignettes are rendered in a consistent layout that makes them easy to browse and easy to find throughout the platform. And then finally, something I wanted to show. So open science means that content does not get locked into some platform, but is accessible in standard formats. So all of the data that we have that you can see in this dashboard, but also much more information that we have about the packages can be retrieved through APIs. So this API tab shows some example APIs that you can have a look at. So for example, this URL is like ggsec.runiverse.dev/packages, and then the name of the package and the version of the package. And that shows all of the entries that we have for that package in the current database. So in this case, it would return a JSON list of 5 objects, 1 source package and 2 binary packages, 1 for Windows and 1 for Mac. And if you look closer, these are the fields from the description, but there's also many additional fields that we add as part of the build process to store metadata about the package. And you can, of course, read all of this information in R or any other programming language that has a JSON client. So thereby, both the data and metadata about a single package, but also about your entire repository and even about the entire platform is exposed, so you can quickly read what is all of the current information that is in the system through APIs. And then the platform provides several more global feeds. So what I showed so far is specific to one particular universe, so one particular user. But then, like, for example, on GitHub, the idea is that we connect and cross-reference all of these universes through global feeds. So you can sort of see everything that's going on today, or like what certain maintainer is working on. So if you go on runiverse.dev on the website to the builds tab, you can see everything that is all of the commits in all of the packages across all of the universes sorted by date. So if you go there today, you see all of the packages that have today had commits. So you can sort of see which things are active and who's working on what. Similarly, for the global articles feed, you can see all of the vignettes that have been updated, or like newly created vignettes, which is sort of a cool way to keep a finger on the pulse on like what's new and what are people working on. There's often like very some interesting content being published there that you can discover interesting things. And also there's this maintainer tab, which is the all of the package updates aggregated by the maintainer. So the maintainer is the email address of the maintainer in the package description file. So many package authors are active in different organizations, and here they get aggregated across all of that. So you can sort of go to your favorite package maintainer and see which things they've been working on in which different organizations, and you can sort of get an aggregate on that level. All right, so that was briefly a recap of what this system is. Again, the talk at UseR gives some more examples and some more use cases of who are using this. But I thought that for this talk, maybe it's fun to explain a little bit about how this was designed, which I imagine is interesting for Bioconductor. Yeah, so that's what I will focus on in the remaining slides, and hopefully we can then discuss a bit about how this compares to Bioconductor. All right, so the RUniverse build system.
Can I ask just in passing? I noticed as I was following along at home that one of the maintainers is Bioconductor, and I was wondering how that. Did you scrape that from GitHub or something like that, or?
I think these are the Git packages that are stored under /bioconductor on GitHub.
I see, yeah.
And then they are, and that have, it's scraped from the Bioconductor index file. If the package in the URL field has a reference to a particular Git repository, then we use that.
I see.
All right, so a quick overview of how this is designed. So the first year of the project, we iterated over like several designs, and finally we sort of arrived at something that allows us to sort of decouple, I think, what are the three sort of core problems to set up a system like this. So I'm pretty happy that we arrived at this here. This is so these are the sort of the three main components of the system. So the first part are the source monorepos, which I will show. I will show each of these in a little bit. So the monorepo is sort of where we track the state of each of the universes. So it's how we manage, how the user controls what's in the repository, and how we track for changes. And then the second part is the build workflow. So this is like an extensible build chain that builds, whenever there's a commit to any of the packages, it starts building the source package and the documentation and the binaries, and then like do some analysis and so on. So that's where the building happens. And then finally, there is the deployment phase. So all of this stuff that we build, it gets pushed to a package server that I wrote, which is the piece I'm most proud of. So as I will show in a bit, I think most are package repositories. I'm not sure if Bioconductor works the same way, but they're created out of static files. So basically you generate all of these package files, and then you run in R, there's a function like write index, I don't know, it's called write something. And then it sort of generates the index file, the packages file for that contains the metadata for all of these packages. And then that is your repository. And what we do is different. So everything is dynamic. There's nothing static. So everything is powered by a very big database with with what I call a package server. So there's nothing is fixed or static in the entire infrastructure. So when we deploy packages, those are inserted into a database together with all of the metadata. And whenever anything is retrieved from, whenever you install a package, or whenever whenever R downloads the capital packages file, which has the index of all of the packages in the repository, or whenever you call off the APIs, all of that content is dynamically generated from the content in the database at that exact point. So that gives us a lot of control over things we can expose about the package repository, much more than if we would have sort of just generate these things statically. All right, so how does it work? The user, so the owner of the universe, the owner of the package repository, they only have to provide this file, which is what we call the registry file. Basically, it's just a list of the Git URLs where we can find your R packages, where we have to git clone the R packages from. And then optionally, you can specify the branch you want to track. So that is like which, if you commit to that branch, then it will be published in your universe. And that's everything as the owner of the universe that you have to supply, nothing else. Then that's all we need. And then what happens is the system automatically creates a so-called monorepo under the R universe GitHub organization. And in the monorepo, each package in your repository becomes a Git submodule. And so our systems automatically create all of these monorepos. So if you go to github.com/runiverse, you see a monorepo for each of these 350 or so organizations that are currently active. And in every monorepo, every package in the repository is a submodule. So our systems automatically sync all of the changes that you make in your registry file, or any commit to any R package in any of your Git repositories. Our systems automatically monitor all of that, and then they push updates to your monorepo. So it moves the references of these submodules to your new commit, or it adds or removes packages as you update your registry file. So the monorepo is sort of the canonical state of your package repository at any given point in time. So it doesn't actually contain any software itself, but it contains all of the links to all of the Git repositories through submodules, where we can find all of your packages, and it actually contains the links to the exact commit at that point in time where your package was. So this allows you to see what's currently in your universe, but also to sort of go back at any given point in time, like what at that point in time, which packages and which versions of all of the packages were in your package repository. So that gives us sort of, before we build anything, it gives us the absolute truth of what is supposed to be in the R package repository currently and at any given point in time. And so you can go to the commit log and you can see all of the packages that are updated and when. So that's the first sort of core piece of the build system. It's this idea of monorepos where we aggregate all of your Git repositories through submodules. All right, and then the second part is the CI workflow. So every time a package gets updated, so whenever you commit an update to any of your packages, our system will then automatically update the monorepo. And whenever a package in your monorepo gets updated, it triggers this series of actions, of build steps. Currently, this entirely runs on GitHub Actions. In theory, we could also host it on our own servers, but GitHub Actions is currently very convenient for this. It works super well. So what happens is that whenever any of the packages in your monorepo gets updated, all of these steps start to appear. So then first, we built the source package, and we built the package sound documentation, and then we built the binary packages for Windows and Mac. And then also, as part of the build process, we collect some metadata and we analyze some things. So for example, we analyze if your package has system dependencies, what if it contains vignettes, and if it passes checks and so on. And then finally, in the last step, or the one but last step, it gets deployed to the package server. So then all of this stuff that we built, GitHub Actions pushes it to our package server. So it uploads these artifacts, so the source package, the binary packages, and all of the metadata that we have about the package, and then it is immediately live. Like GitHub Action pushes it, and 1 second later, users can start to install things, and like your dashboard gets updated and so on. So yeah, the final part is this package server that I wrote. Yeah, I won't go into details, but it's a stack based on MongoDB and Node.js, and so it makes this entire thing dynamic, right? So this is what allows us to create these dashboards and these feeds, and we also added a lot of, like in the last few weeks we added like badges, and this week we added like RSS feeds and so on. And all of this is pretty trivial to add because there's just we have a database and it contains all of the information we have about all of the packages, and basically these APIs just have to pull some information from the database and then generate the badge or the content from that. So there's nothing is static. So honestly, I have no idea how Bioconductor works and if they have something similar or if everything is just static. But I think that this piece is like something that's in some form or another. It's very promising to go to a database design for package repositories rather than just carrying around all of these static files and like regenerating static things. Yeah. Yeah, and then the package server, maybe I can show that in a bit. Actually, maybe I can show it right now. I'm not sure if maybe it's too small, but I just want to show that. So this is what you see in the background is the package server, and then whenever we like go to a dashboard, you can see that it starts pulling information from this package server. So, for example, if I open the badges tab, you start seeing all of these requests, yeah. So, for example, if I would install an R package, let me increase the font size a bit. I'm not sure if it's clear what I'm doing, but the background is like the server. It's very small, and the foreground is me. Yeah, so my R is now installing this package from the server, and here in the background you can see that first it like looked for the index in the packages file, and then it somewhere here it downloaded the actual here we go, magic. So it downloaded it pulled the R package from the database and then streamed it to R. So there was no, the point I wanted to make is that there's no nothing is static. Like everything is done on the fly, on demand. Yeah, and that allows us to do like a lot of other things, right? So something we added this week is, for example, an RSS feed, and it's just as easy, right? So an RSS feed is like an XML form. An XML format of the content in your repository ordered by date, and it's everything's in database. So it's just a query like give me the latest 50 packages sorted by update, and then like put it in this XML format, and and there you go. So yeah, so that's sort of makes it a very versatile system, and it allows us to easily add more cool stuff and useful stuff on top of that allow you to show more information and do more cool things with your R package repository. Yeah, so this is my final slide. It doesn't really fit on the screen. This is what I also have on one of the blog posts, and it sort of gives an overview of the process. So it starts with this registry file that the user has, which shows the URL of the Git repository and the branch. From that, our system automatically creates these monorepos where we track. We look for changes and commits in the registry file and in these Git package repositories, and we track and commit all of those to a monorepo. And that whenever something changes, we build all of these things, the source packages and the binary packages and the vignettes, and then we some metadata, and then we push all of that to the package server, to the deployment server, and from there things become available both for R, for installation through installable packages, but also through APIs and feeds and dashboards and so on. And these vignettes become easy to browse. So yeah, through that we sort of hope to create a platform that makes it attractive to publish more things as R packages without having to do any gatekeeping or sort of any too much editorial work as you would do in a centralized repository like Bioconductor or CRAN. All right, I'll leave it at that. So
that's totally amazing, really wonderful. Yeah, lots of things in there are really interesting and innovative. So I'm looking forward to what people have to say on the call.
Jeroen, you had a bullet on health metrics early on. Can you say something about that?
Yes, so it's sort of Right, so it's the part that's least developed, but something that is that we want to do, and we have other people also involved in that. So we believe strongly at our open site that it's important that when you use an R package, you have some sense of the health of that package. Like, is it still actively developed? Like, does it have a lot of bugs? Like, what's the role in the ecosystem? Is it like very established or like sort of up and coming, or is it like an abandoned package? And like the role in the dependency network, like, do a lot of things depend on it or not, or does it depend on a lot of things? So yeah, part of this project and also the grant is that we try to, on top of this system, we try to add information that is informative for a potential user of research software to get a sense of like, is this something that I want to build my research on, or is this something that I should avoid? And yeah, so we're that's part of the project, and we have so we're doing something like the database. I'm working on some features to do network analysis automatically on the package repositories, because we have all of this information in the database about the packages, but also the dependency network. So we basically have a graph in the database of a live graph of the packages and the dependencies. So we can live do some metrics about like some basic network analysis, or like and we there's basic things like we can show you download statistics and so on. But there's also other things like we were collaborating with a group of researchers that do AI, trying to look for citations and use of software in public open access articles, or like, for example, scripts on GitHub and so on. So that's another direction that we're trying to do something. What we would really like to see is, like, for example, if you go to this platform and you see that there's a certain package published by a certain author, that you can that we immediately also try to show you like which are articles that this package has been used in, and like, has this package been cited, and like, is this like other packages depending on this package, or are other some packages are of course more end user packages, so are like other people and researchers depending on this package. Like, basically everything that we could think of that could be informative for you if you want to decide, like, is this something that I want to use, or is this going to be a liability in my project? But I mean, this is definitely a softer part of the project. It's it's very difficult, of course, and these metrics are very subjective and sort of depending on your field and the situation. Like, some metrics may be more informative than others.
If people are being quiet, I'll just say just two words here about Bioconductor, and maybe some of the differences between what you've described and how things work. So this is a typical Bioconductor package, genomic ranges. It has a landing page. I guess we tried to capture some metrics up here about what platforms it's supported on, how frequently it's downloaded. This is information about our support site, how long it's been around, when it was last updated, and the dependencies, as well as all of the reverse dependencies. So in some ways, that's the presentation. When you install this package, it installs from a static repository. So it's the classic CRAN, as opposed to something dynamic like your CRAN-like server, which I think is totally awesome. Not that we do it the old way, but that you do it the new way. And then we also have nightly builds, and every night, all the packages are built in the in the order that is implied by the dependency graph. And that's done because I guess the dependency graph in Bioconductor is much richer than in than in CRAN, say. And so changes in genomic ranges can totally break other packages that depend on it. And we don't want to be publishing packages that are broken because of the dependency has been modified. And then you also mentioned about, I'll just say one more thing, but other people can probably chime in. There's some much more knowledgeable people on the call than me, but we do have, so I said we had nightly builds. We actually have a release branch and a devel branch. They're both built approximately nightly. And so that, that write packages, the repository gets updated daily. The devel branch is meant for new features, new packages and new features. The release branch is meant for bug fixes. And every 6 months, the devel branch rolls over to the release branch. So the idea is the user uses the release branch, they get something that's stable and tested, modular bug fixes, and then those living on the edge can develop and innovate and clean up after the havoc they wreck in the devel branch. I think it's actually a really good model. It's allowed us to
I think so.
develop.
I wish CRAN would adopt it, but they won't. But yeah, it's like it completely makes sense to have a stable branch for your repository.
Yeah. I also wanted to say that all of these guys, we do have Git repositories for packages that we maintain, but actually we have git.bioconductor.org, which is like the canonical location of our packages. So I was kind of wondering about the scalability of your approach and whether you sort of tested that or looked at the consequences of like mirroring all of CRAN or something like that.
Yeah, so we're slowly scaling up. And of course, there's these different components about scalability. So the package server, I'm not super worried about because, well, I mean, it's like a large package repository is like 10,000 packages, but on a database, that's nothing, right? Like 10,000 is not something that's a millisecond to search. So that's no, I mean, like you're going to need some disk space if you want to store a lot of these things, but that's not a problem. But like the expensive part is, of course, building all of these things, right? So currently we use GitHub Actions, which seems fine. So I guess currently we have like a few, like 100 or like a few hundred commits every day. So then that means like, say there's 100 packages with an update. Well, it's more actually. I think there's 200 like per day. So say you have 200 package updates on a day, then that's 200 source packages, and then that's 1,000 builds for Windows and 1,000 builds for Mac. So that's not too bad. But yeah, if that would be the problematic part if you want to scale up. And actually, like doing it the CRAN way wouldn't even be very expensive because CRAN, of course, they accept very limited updates for packages. So they like a CRAN package is not allowed to update more than once per week. So that's actually not very expensive to build because, at the end of the day, they also have only 100 updates per day. But we allow infinite updates basically. So we constantly track these Git repositories. So it's easy, a single package can get updated 10 times per day or something. So yeah, if you do that for thousands of packages, then, it may add up. Although my sense so far is that even in the total R ecosystem, the activity is, there's like, it seems that a lot of the R development activity is like focused, like at least half of it is like a dozen of the usual suspects who are generating all of the activity. And then there's like some other package developers. So I think that we could easily, right now we could easily track the entire R ecosystem, but we actually do want to encourage people to start creating R packages for everything, right? That's part of this project. Like if you have an homework assignment or like a cool, if you write a tutorial or something, like turn it into a vignette, and then, you know, just create an R package around it with the dependencies of the vignette, and then put it in your universe. And then like it becomes this live rendered thing that you can publish. So if people would do that on a large scale, then of course the scaling becomes more tricky, right? Because then, but I mean, so far, it seems that I don't think it's going to be a problem soon. And also, I mean, the computing resources are just growing so fast these days that it's getting like even the free CI tiers are getting cheaper and cheaper, and like, so I think we can keep up with that.
Jeroen, I'm not too knowledgeable about GitHub Actions. Are the actions being run under the user's GitHub identity, or do you do them in your organization?
No, right now we do them. We do them in our organization. So we purchase like a pro plan, and then you get like, I think it's like 60 concurrent build servers, basically, or like concurrent jobs. So it's and then, you know, if I don't think we hit that kind of concurrency soon, but if we do, then they just get queued up, and then so it works pretty well. So right now there's no if GitHub stays as generous as they are, there's not going to be any problem. But GitHub is like, even if we would surpass sort of what's allowed on their public infrastructure, GitHub is pretty good that you can plug in your own runners. So you can, the runner is basically your own server. And then with minimal configuration, you can just hook that up to their CI system, and then they start using your own resources to do all that building. So then that's sort of nice, because then they take care of the complexity and the management, and you can just scale up by sort of renting a few big servers and then configuring those as runners. But I mean, R is big, but it's not that big. I mean, Gran has been running the entire Windows build infrastructure on one server for the past 12 years that they've never replaced. And I'm not sure if Bioconductor has more than one build server, but it's like, it's on the grand scale of things. Right now, I'm not super worried about scalability.
I guess we do the full builds, like all packages every day. So that's it basically occupies a server for most of the day. I think Konstantin had a question, or at least he showed up.
Yes, yeah, right. So I had a question actually. So first of all, I want to thank you for the great talk, and I think it's a very impressive project. I was wondering how much people are actually already taking it up. So if you can already see in terms of downloads, how many people are downloading packages via the R universe instead of CRAN, or maybe for unpublished packages, how much they are downloaded. I guess it's definitely difficult to compare against dev tools. Install GitHub, but maybe if any sense of that.
Yeah, the download sticks are tricky. And the reason why they are tricky is because, okay, I didn't explain this, but in the universe, when you build a package, the universe itself is used as one of the dependency repositories. So like if you have like in ROpenSci, if you build a package in ROpenSci, all of the dependencies that are available from our own universe are taken from our own universe, and only the remaining ones are taken from CRAN or Bioconductor. So that really inflates the download statistics, of course, because basically whenever one package depends on another package in the same universe, it creates a download. So yeah, so for the download statistics, something I need to work on is distinguishing better between which are automatically generated and pulled in as part of a dependency in the build system, and which are actual user downloads. But that's of course always a problem, because even if you know that, then you know if the user installs something, then you also still don't know if they really wanted that package or if it just was a dependency and so on. So it's hard that's a difficult metric. But one thing that we do see is a lot of people start to set up these things, which is sort of cool, and they talk about it, and we can see, of course, that people visiting the dashboards and so on. So we see there's some uptake in that. But
because that was also kind of the motivation. I was now thinking, should I make this like should I add my packages in there as well? What would be the downside? What's the upside? How much do I win by that? How many more people do I reach which I wouldn't otherwise?
Well, it's very easy to do, so you can try and then
see what happens.
Yes, excellent.
So Hervé asked in the chat, do you run R? So Hervé is basically the build master, has been running our build system for the last, since 2005 at least. Do you run R command check on packages, and is the output available somewhere?
Yes. So let me go back to the. Can you see my screen again?
Yeah.
I guess it's very small right now. Yeah, so if you go to a dashboard, then you see these icons. Green means that RCMD check passed, and gray means that the package build was successful, but RCMD check didn't pass. So let me look at this one, because this one didn't pass. So if you click on it, boom, you go to the, it's very small, I guess. You go to the to this workflow, and then indeed you see like the source package was successful, but then the Windows and the Windows packages, they had an issue. So if you click on it, it takes you to the build logs. So here you see for this particular step in the workflow, I hope that's right terminology. Then you see the different. No, this is an action. This is called steps. Anyway, so here for these Windows builds, you see these different steps. So installs R, and then it gets a source package, and then does build and check. And then here you can go to the check log. So here you can. This is the output from CMD check, of course. And then we see what was the error, why this package failed the check. But even though it failed the check, the build was still successful, and therefore it is still available for installation. Sometimes if it completely fails to build, it also shows up. Let me see if we have an example. Oh, wait, maybe Bioconductor because it's quite a lot of fails here. No, I can't find any failures. Yeah, I don't know. Anyway, so if there's a complete failure, it will also show up, and then it will. Well, if there's a red cross, it means that the package didn't build at all. So I guess that is expected for Bioconductor, that some packages don't build anymore on the previous version of R. And I know that I'm very aware Bioconductor is not intended for that, because you guys have a different release cycle, and every Bioconductor version is only supposed to work with the latest version of R. But for this is the way the thing works for most people. So we build the same way. So here is the packages that are available from the Bioconductor organization on GitHub, and it is bioconductor.universe.dev. And then you see that these two packages worked for, they could be built on R4.1, but not on R4.0. And so if you would click on it, you would be able to see why. It's probably just a version requirement. Yeah, and depends on some other version that is not available. Anyway, yeah, so everything is available through the GitHub Actions logs that are linked both from the dashboards and also through GitHub.
It sounds like your Monorepo specification allows you to state the branch. Does it allow you to map a branch to a version of R, or because that might rectify that?
No, I'm not sure if that would be doable. I mean, right now there's just one state. I mean, it's like CRAN, right? That part's of course modeled after CRAN. There's one version of every package, and then we try to build binaries for the current and the previous version of R. That part's of course different than Bioconductor, where you have different versions of the package for different versions of R. That's sort of a harder problem that doesn't have it's really a different school of design, I guess. But it would be cool to one thing that we do support is that some people don't want to track a branch of their package, but only releases. So in Git, you can tag your release when you can just tag releases, right, of your package repositories. But GitHub also has this notion of it's called semicolon latest release, which is simply just the last tag in your repository. And we allow you to specify that as a tracker. So that allows you to create a package repository, which contains, which only updates the packages in your monorepo whenever you tag a new version, and then it sort of moves the submodule to the new tag. So that's a way you could, if you don't want to be like super bleeding edge, and you're like, oh, I only want to push stuff into my into my universe that is released. That's another way you can control this yourself, and you can, in your registry file, you can specify just instead of a branch, track the latest release tag.
Amazingly enough, we're just at the end of the hour, and I don't know whether people want to continue on. I actually have another appointment to go to, but I'm happy to. I'm somehow, maybe I could pass the baton back to, I'm not sure who, to someone who's going to stay. Are you there, Vince, for a while?
I could stay another 10 minutes. So if you want to pass the host to me, that's fine.
I'll try and do that. I don't know how to do that, but probably. I'll tell you what, I'll just turn my camera off and mute off, and you guys can carry on. It'll be fun. All right.
Any questions?
Yeah.
Would you have feature suggestions? So we're trying to make this more useful, right, for a range of different use cases and audiences, except for the version thing, what I'm aware of, which is tricky. What is the sort of, if we could add a feature to expose something about a package repository that you control, what would be cool, or what would you find useful to expose?
So I actually have a question. Is it possible to get the system requirements for each of the packages through some API call?
Yes. There is let me share my screen again. Cool. Yeah, so what's a good example? Maybe rlib. Maybe rspatial is good because they have a lot of system dependencies. Well, it's a few. Yeah, so we automatically when we build the source package, we automatically analyze which system dependencies the package was linked to, which is in this column here, you see, the last column. And then that's also available through API from the top of my head.
And So I guess my main question is like, how did you guys figure that out for the free-form system requirements fields?
No, I developed something else. So when you it's much better than it. So the when you have installed a package, you can look at the shared library. So you can call it LDD on the shared library, and that shows you on Linux which other shared libraries a package is linked to, and then you can track that back to which Linux package contains that package. And I've actually written a vignette about that, if you're interested in this. So the package is called Make Tools. It's on CRAN. There you go. Yeah, so if you're interested in see how this works, the package in which I implemented this is called Make Tools. And then there's this vignette in which I explain how this works. But basically what we do is we just run this, Make Tools package sysdeps, and then that will give you it will show you once the package is installed, what the package is linked to. But of course, this requires that the package is already installed. So it's not,
right.
So it's not, you cannot use this like before you install the package.
Mm-hmm.
So what we do is we have the source package. We use a very big Debian Docker container, which has like almost everything pre-installed on it. So that means that almost every system dependency used by any R package is pre-installed on the thing.
Right.
So if you install the R package, it usually works. And then after you install the R package, you can use this tool, and it will analyze what system libraries the package actually ended up linking to.
I see.
And that is the information that we show on the dashboard.
I see. This is very helpful. Thank you. That's a fantastic tool. I'll be using it for sure. Thank you.
Other questions? Suggestions?
Well, I don't want to have the airways, but yeah, this is the time. Go.
I have another question actually. So for the GitHub Actions, do you develop your own runners and then have the action work on those GitHub runners, or?
No, we use the public runners.
Okay.
So we, so that means there's some overhead in every everything, like the first minute or sometimes two is spent installing some other things. But it's in terms of like complexity, it's at this point it's easier than running your own runner, because
that makes sense. And I just wanted to ask one more question, which is, so you show a Windows and a Mac build as well. Is that happening on GitHub as well? No, right?
Yes, everything's happening on GitHub.
I see. There are runners on Windows and Mac on GitHub now? Oh, I see. Okay. Okay.
So does the user have to write the workflow YAML, or you have a standard?
Nothing. Absolutely nothing. The only thing you need is a registry file. So that's the only thing that the user applies, is basically give us a list of the packages you want to track, and optionally which branch you want us to track. That's it. There's zero setup, zero configuration, everything like you. And there's a few blog posts that outline if you want to set this up for yourself. But basically you create this registry file and you put it somewhere in your GitHub, and then you have to install this GitHub app, which sort of gives us a sign that we should start following you, and then everything will just magically start appearing.
I'm going to have to run in a minute or two, but I would like to just see about this idea of symbiosis, right? There's a lot of stuff that Bioconductor does that I think sort of overlaps. with what you're doing in terms of building and distribution and so forth. But I think there are some very attractive approaches, let's say, to article production and publicization and so on. And I'm just trying to get a handle on where, if you're a bioconductor developer, let's say, you put your package in our system, but there are things about the R universe that we don't provide, let's say. I guess, we need to look at that more carefully, but the question is just how to leverage the things that you're doing there for things like articles or vignettes, let's say, that this makes them, somehow more attractive and more accessible than they might be if you just use bioconductors vehicles for dissemination.
Yeah, for sure. We would love to explore collaborations, and also, we're sort of pioneering a lot of things and trying things, and some of them turn out to be interesting, and some of them very much not so. So, like, it would be, we very much hope that if there's things that in our experimental platform turn out to be very useful, like, of course, we are happy to see you copy those sort of things, or like help you do similar things. Like the system dependencies thing that I just shown. I think I've asked CRAN, like, you should do that. It would be super useful. Is on the CRAN homepage, you can show the system dependencies of a package so that people don't have to guess from this free form field, like, which Debian package do I need? No, you actually, like CRAN, you have installed the package and you've checked the package, so you can know which system dependencies the package links to. So just publish that information. They haven't responded, but I mean, that's something that I would hope people would like steal from us, because it's like useful, hopefully.
Any concepts of user experience evaluation? Are you doing surveys or focus groups or whatever to get a sense for how people are taking advantage of this?
No, we're not there yet. I mean, it's pretty early, and we're still actually, it's just starting this summer. We sort of opened it up for the general public. We were earlier this year, we were piloting, and I'm mostly still sort of adding features and like tweaking the infrastructure and so on. So at this point, we're not at the point yet where we can really evaluate what users are doing, but we hope to at least through like feedback and input from like groups like yours, but also very different sorts of audiences, get a sense of like, okay, how can we make these more useful and more attractive for people to start publishing their things in a way that exposes their research software or their research in a way that allows that gives us much more visibility and like much more use than just putting it somewhere in your GitHub or something.
Yeah, I'm gonna have to run off, but I think it'll keep going. So thanks very much. We'll see you.
Actually, I also have to get dinner because it's like getting late here.
Thanks so much.
Thank you so much.
Great to hear you talk. Thank you.
Thanks, guys. And if anyone, anything comes up, or if you have any ideas or questions later on, send me an email or ping me on Slack. Thanks. Good night.